Today we're going to be talking about parallel lines and transversals. So first, let's talk about what a parallel line is. So these two lines here are parallel lines, and we know that they are parallel lines because parallel lines are coplanar. They're going to lie in the same plane, and they don't ever touch. And so our math word for that is intersect. So these do not intersect. And a couple of ways that they may tell you that lines are parallel. They may put a little arrow on the lines, and those can look either like this, where they're just an open arrow, or sometimes like in your book, they may have them where they're a closed arrow and they're shaded in. Okay. Or they may tell you in the names, so they may say line AB is parallel to line CD. And so this symbol here, the two parallel vertical lines, this means parallel. And again, that means that these lines, no matter how far they go, because they all have arrows at the end, they're never going to touch. Okay, so they're going to go on forever, and those two lines will never touch. Okay. We also have skew lines, so let's look at those. So skew lines have to be drawn on some kind of 3D figure, or they have to give you at least two planes, because skew lines are not coplanar. So they are not on the same plane. And like parallel lines, they do not intersect, so they won't touch. Okay. So for example here, we might say line SR and line MQ are skew lines. And there's no special symbol for those. We would just write it out as SR and MQ are skew lines. You have lots of options on a cube for skew lines, so these are not the only two. You could have chosen LM and NR as skew lines. This would also work. Or you could choose PQ back here and OS. So those will never touch. And I realized that it looks like if I keep drawing any of these lines that they would eventually run into each other. But you have to remember that this is a 2D drawing of a 3D figure. So if you look at an actual box and you were to look at these lines on an actual three-dimensional figure, it'll help you see that if those lines, like those edges of the box, continue forever, they're never going to run into each other. So just be really careful as you think about this, that you remember that this really is a 3D figure. Okay. Next, we're going to talk about parallel planes. And so parallel planes are also going to be on a 3D figure. And usually they're drawn on something like a box or like a cube, this one, or a prism of some sort. And so when we're talking about parallel planes, we're interested in planes that do not intersect. Okay. They obviously can't be coplanar like parallel lines because they are planes. But the key thing here is going to be that these are planes that do not intersect. So, for example, it would be like the left side of this box and the right side of this box. They're going to go up and down and left and right forever and ever, but they're never going to touch. And the easiest real-world example I can think of this would be like slices of bread, where if they could stand up on their own, then you would have a whole bunch of planes right there, and they're all parallel because they don't ever have to touch. Right? You could put just a little bit of space in between each one of them. They would be parallel, they wouldn't touch, and they would go on forever. When you write these, we name a plane with 3 letters. So I would have plane LPS is parallel. Sorry, that should have the word plane in front of it. So plane LPS is parallel to plane RNN. And remember, it doesn't matter which 3 letters, as long as you choose three letters that are all on that plane, and they are not coplanar. Sorry, not collinear. So they can't form a straight line. So any three of the vertices that form our planes would work. Okay. And again, you have lots of options here for parallel planes. You could use the top and the bottom of the box as parallel planes. That would work. You could use the front and the back of the box as parallel planes, and that would work. Okay. So next we're going to talk about lines cut by a transversal. In this case, we're specifically interested in parallel lines that are cut by a transversal, and we're going to name the angles that they create. Okay. So first of all, these names are going to work no matter whether the lines are parallel or not. If they're parallel lines, then they're going to have some special properties that are really important. And so we'll talk specifically about those over the next couple of days. And so, again, you would know lines P and Q are parallel because they would have the little arrows. And again, they may be open arrows or filled in arrows. It doesn't matter which one, but those will actually be on the line. Not talking about the arrows like this one at the end of the line. Okay, those are different. And so then we also have to be able to identify those two lines, and we have to be able to identify the transversal. So if you look in your book, the transversal is going to be a line that intersects two or more coplanar lines at two different points. Okay, so notice P and Q are intersected by line R here and here. That's two different points. Okay, and that's going to be really important. So that means that this line, line R, is our transversal. And if you would like to draw this picture, the next four terms we're going to talk about all use the same picture. So you won't have to redraw it multiple times. Okay? So that's our transversal. So the first thing we need to be able to identify are the point, or the angles, excuse me, on the interior of the parallel lines and the angles on the exterior of the parallel lines. Okay? So on the interior means between these two parallel lines. So if you think about the parallel lines, that they were going to move towards each other, okay, then that's going to give you a good idea about all of our interior angles. So all of these angles inside here are interior angles. So if you wanted to write them down, that would be angle 3 and 4 and 5 and 6. Those are all interior angles. That means all of the angles away from each other, like if the parallel lines are going to move away from each other, these are all exterior angles. Okay. And you're going to notice that there are 4 of each. Okay, so on here, based on my colors, the blue are exterior, okay, and the green ones are interior. And if you shade these using something like a matte pencil, then you can still see the numbers a little bit better. Okay, so our exterior angles would be angles 1 and 2 and 8 and 7, in case you're listing those out. Okay, so now let's talk about some specific angle pairs here. All right, so you clear all of that. And so the first thing that we're interested in are consecutive interior angles. These are also called same-side interior angles. So if you were given these in the past, or you learned these names in the past, then you might have learned them as same-side interior. And so these are consecutive interior angles. Okay? So everything you need is in the name. Okay? Consecutive means that they are going to be on the same side of the transversal, and interior means that they're going to be inside of the parallel lines. So we're looking at this angle here and this angle here. Notice that they're on the same side of our transversal, and they're on the inside of lines P and Q. Okay, so they're interior angles. So angle 3 and angle 5 are consecutive interior angles. I'm going to give you a second, and I want you to see if you can find the other consecutive interior angles. That's right. It's going to be angles 4 and 6. those are also consecutive interior angles. All right, so let's try the next one. Next, we are going to have alternate interior angles. Okay, so again, everything you need to know is in the name, right? Alternate means that they are on alternating sides of the transversal, so opposite sides, and interior means that they are on the interior of the parallel lines. So 3 and 6 are on opposite sides of the transversal, and they are also inside lines P and Q. Our other alternate interior angles are 4 and 5. Because they are also on opposite sides of the transversal and inside the two parallel lines. Okay, next one. So next we're dealing with alternate exterior angles. And alternate exterior angles have to be on opposite sides of the transversal, and they have to be on the exterior of P and Q. So that would be like angles 1 and 7, or like angles 2 and 8. They're on opposite sides of the transversal and on the outside of the exterior of P and Q. One more. Okay, these, for some reason, are the hardest for most students to remember and recognize, and I'm not really sure why, but they're called corresponding angles, and corresponding just means that they are in a corresponding position. So I like to think of my top set of angles up here as like team 1, okay? And my bottom set of angles down here is like team 2. And so I think of these as they're angles that play the same position. So for example, angle 1 and angle 5 are corresponding because they are both in the top left corner of their team. Okay? Angle 2 and angle 6 are corresponding because they are in the top right corner of their team. Okay. Angles 4 and 7 are in the bottom right corner of their team. And angles 3 and 8 are in the bottom left corner of their team. So I think if you'll think about them as two separate teams, and then corresponding just means they're the same position but on a different team, that will really help you out. I hope that you enjoyed this, and I hope you have a lovely afternoon. Thank you very much. Have a good night.